Welcome to Brain Vision.
Hello. So we're going to talk about this question about these dialysis bags having semipermeable membranes that's impermeable to sucrose, but I assume it's permeable to other things like water. And it's filled with various concentrations of sucrose and placed in separate beakers, having the initial concentration. And at 10-minute intervals, they're masked and the percent change is graphed, as seen below. So which line or lines represent the bag that contains a solution that's hypertonic at 15 minutes? So if we remember, hypertonic equals hyper is higher. So what this means is that it's going to have a higher tonicity. So that means it's going to be greater than 0.6 molar. Because we see that it's placed in a beaker, so the outside of it. So the solution that's outside, 0.6 molar. And then the dialysis bag that's inside, it's going to be something greater than 0.6 because it's hypertonic, so it has to have a higher tonicity, so it's going to have a higher concentration, right? Okay, so we're looking at something that's going to have a higher concentration when it hits 50 minutes. So we're going to look at all of these graph points at the 50-minute mark. One of the things that we're going to be looking at is that this is the net mass change. And so the mass change is going to be equivalent to like the movement of, we're going to call it water in/out of the bag. So when you have this percent of mass change, that means that there is a difference in the tonicity, right? Because that means something is still changing, so it hasn't reached an equilibrium yet. So if there is no mass change, it's at equilibrium. So then it's going to be 0.6 molar, or not necessarily 0.6, but it's going to have equilibrated so that it's going to be equal to the inside and outside. Are isotonic. Iso means same. Tonic is the tonicity of the concentration. So when we're looking at this point at the 50, anything that has no change in the mass or very little is probably not going to be part of the hypertonic. So that immediately means we can rule out E, C, and A, because at that point they've all basically reached equilibrium. So now we're between B and D. So we're talking about a solution that's hypertonic. So that means it has a higher tonicity. So for equilibrium to be reached, it wants to decrease the tonicity. And how does it do that? Because it can't move sucrose, it's going to increase the water to dilute it, right? Because if you have all these different masses across this line, blah, 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 just this quick example. And you see there's fewer dots over here versus over here. I'll make it a little bit more obvious. You see all these dots? Where's the water going to move? The water is going to move over here so that it can start making so that this becomes the same tonicity of the same number of units of solute per water that's in there. So it's going to try to increase this by decreasing until they're at the same concentration, until it goes into something. They'll end up being like, just for this quick example, I'll show. And it's going to be this big water versus this tiny, so that they technically have the same solute concentration per unit. So basically, after all of that talking, what am I saying? I'm saying that to find the hypertonic solution, we have to find something that the mass change is going to be positive because water is moving into it. So out of B and D, which one has a positive mass change? As we see D, it's showing a negative. So I'd say no on D. So it looks like B is going to be our best option, which should be this one. So B should be hypertonic. Tonic at 50 minutes. All right. Hopefully that all makes sense, and definitely go through it. Make sure you understand tonicity and the terms hypo, hyper, and iso, and the net movement of solutes and equilibriums. all of this is just basically putting everything together and making sure that you understand these concepts, right? All right, good luck. You can do this. You're going to ace this class and this whole question and every test. Good job.